In the early days of World War II, American factories faced an overwhelming challenge: to produce tanks faster than the enemy could destroy them. The U.S. Army needed thousands of armored vehicles, yet every tank still required weeks of hand fitting and custom assembly. Each part was machined differently, each plate welded by eye. Efficiency was a luxury war could not afford. But then, in Detroit, an engineer named William Knudsen, a man who had once designed cars, looked at the problem differently. He didn't see a production crisis. He saw a blueprint waiting to be simplified. His vision would soon merge the spirit of Detroit's auto plants with the grit of the battlefield. Knudsen realized that if cars could be built by the thousands, so could tanks, if only the process was broken down into repeatable steps. It was an idea that clashed with military tradition, but it sparked something new. America was about to turn its greatest civilian skill, mass production, into its deadliest weapon. Knudsen had earned his reputation as a mechanical genius at General Motors. When the U.S. government called, he left a comfortable career to serve his country. What he brought wasn't just engineering, it was mass production philosophy. To him, every tank was just a complex car, and every car had once been a puzzle until assembly lines solved it. Most military engineers called him naive. You can't mass-produce tanks, they scoffed. The tolerances were too tight, the armor too thick. But Knudsen believed otherwise. He started sketching a flow of machinery, cranes, belts, and people moving like synchronized gears. He imagined tanks moving through factories like vehicles through service bays, each stage building upon the last. His concept demanded rethinking not only machines, but how workers interacted with them. In that vision lay the seed of something revolutionary, the world's first true war machine assembly line. His first task was converting the Chrysler automobile plant into something unprecedented, a facility capable of rolling out tanks like Model Ts. It became known as the Detroit Arsenal Tank Plant, the first of its kind. Where cars once gleamed under showroom lights, steel monsters began to take shape. The factory floor stretched for half a mile, lined with welders, riveters, and conveyor belts. For the first time in history, tanks weren't being crafted, they were being manufactured. Knudsen's impossible blueprint had found a home, but many doubted it would actually work. The challenge wasn't just mechanical, it was cultural. Car builders were used to precision and polish, while the military demanded brute strength. Knudsen's genius was to unite both. Under his guidance, Detroit became the front line of innovation, where blue-collar workers and engineers joined forces to build engines of victory. At first, chaos reigned. Auto workers were unfamiliar with tank armor, and machinists used to chrome trim now handled heavy steel plating. Mistakes were constant. Bolts sheared off, gears jammed, engines failed to align. But Knudsen's genius wasn't in design, it was in organization. He restructured the workflow, breaking complex tasks into repeatable motions. Each worker would perfect one step. This was car logic applied to war. Slowly, the confusion melted into rhythm. The line began to move. A miracle was unfolding on the floor of the arsenal. Knudsen also introduced time cycles, ensuring each tank component spent only minutes at each station. Supervisors tracked progress like clockmakers. The roar of hammers became the pulse of production, and every clang echoed a new chapter of efficiency. America was learning to build tanks by the clock. By mid-1942, the line was running smoother than anyone imagined. Tanks now came out in stages, frames, tracks, engines, turrets, each assembled by specialized crews. Chrysler engineers modified jigs and fixtures to allow tank hulls to be swapped like car bodies. Parts became standardized, meaning one factory's components could fit another's tanks. This was revolutionary. The handcrafted war machine was dying, replaced by the science of interchangeability. Each day, the line grew faster, more precise, more confident. The impossible was beginning to look ordinary. Knudsen's system also allowed damaged tanks to be repaired anywhere in the world. Spare parts could be shipped in crates and replaced instantly. What once required an engineer now took a mechanic. For soldiers, it meant survival. For Knudsen, it meant victory through consistency. Reporters visiting the plant were stunned. Tanks seemed to glide across the floor like automobiles. Each one took shape in a matter of hours instead of weeks. Knudsen's approach had unlocked a new kind of wartime power, industrial speed. He wasn't alone, of course. Other automotive giants like Ford and GM followed his model. Soon, Detroit wasn't just the motor city, it was the arsenal of democracy. Behind every Sherman that rolled toward Europe stood Knudsen's blueprint, his belief that efficiency could win wars. Visitors described the plant as a living organism, sparks flying, gears turning, and men and women moving in unison. It was industry turned into performance art. Even President Roosevelt toured the site, declaring it a triumph of American ingenuity through consistency. But it wasn't easy. Every new tank model brought a fresh wave of problems. Blueprints had to be redrawn, molds recast, and workers retrained. Knudsen's leadership style became legendary, walking the floor in rolled-up sleeves, solving issues on the spot. He refused to stay in the office. "The factory is where the war is fought," he'd say. His determination inspired thousands. Under his watch, production didn't just increase, it exploded. Within months, America was producing more tanks than Germany and Japan combined. He knew morale was as vital as machinery. Knudsen often ate lunch beside welders and machinists, listening to their ideas. Many of those shop floor fixes became permanent solutions. His humility was as effective as his engineering. By 1943, Knudsen's method had spread nationwide. In California, aircraft builders borrowed his system. In Pennsylvania, steel mills synced their output to tank factories. America had become one vast synchronized machine. Each bolt, gear, and track was planned to fit perfectly into the next stage, just like his drawings predicted. Even generals began visiting the Detroit arsenal to witness the phenomenon. What they saw wasn't chaos, but choreography. The sound of hammers and engines blended into a steady mechanical heartbeat, the rhythm of victory. Factories communicated like never before, sharing updates through telegraphs and coded reports. Efficiency became a weapon of war. Knudsen's assembly line had united a nation's industries into one unstoppable force. The tanks themselves became icons of Knudsen's dream, most notably the M4 Sherman. Designed for adaptability, it could be built by dozens of plants at once. Every bolt fit, every wheel turned true. Soldiers on the front lines often joked that their Shermans smelled like Detroit. The power of Knudsen's system was more than numbers. It was uniform reliability. When a tank broke down in Africa or Italy, parts from a U.S. plant could replace them immediately. The blueprint had connected the battlefield to the factory floor. The Sherman's success became proof of the system's genius. It wasn't the biggest or strongest tank, but it was always ready. Its simplicity saved lives. Every rolling Sherman was a moving tribute to Knudsen's belief in precision and repeatability. Knudsen's innovations also reshaped America's workforce. Thousands of women entered the plants, learning to weld, rivet, and machine with astonishing skill. The Rosie the Riveter era was born right here. For many, it was their first industrial job, but under Knudsen's streamlined methods, they mastered it quickly. War production became not just an engineering victory, but a social revolution. Every tank carried more than steel and gears. It carried the fingerprints of millions who worked behind the lines. Knudsen personally advocated for hiring women and minorities, insisting skill mattered more than background. His plants became melting pots of determination. In every clang of metal, America's social fabric was changing alongside its machinery. Even British and Soviet observers marveled at what they saw. They called it the miracle of Detroit. Soviet factories tried to emulate it, but none achieved Knudsen's seamless flow. His blueprint had transcended engineering. It was now a symbol of American efficiency. When tanks were loaded onto ships for D-Day, Knudsen's vision had touched every bolt and gear. His once impossible dream was crossing the Atlantic to decide the fate of nations. To the Allies, Detroit became as strategic as any battlefield. Every day, new machines arrived at ports faster than the enemy could destroy them. Knudsen had weaponized time itself. But behind the triumph lay exhaustion. Knudsen worked tirelessly, often sleeping in his office. The endless noise of assembly lines became his lullaby. He wasn't chasing fame, only output. By 1944, the arsenal could produce a new tank every 57 minutes. This staggering speed had once been unthinkable. Even skeptics admitted defeat. Knudsen's blueprint wasn't just efficient, it was unstoppable. The U.S. war machine had become the most powerful on Earth. Yet Knudsen rarely smiled at the numbers. He carried the burden of knowing that each tank built was meant for war. To him, the sound of production was both pride and sorrow intertwined. When the war ended in 1945, Knudsen quietly stepped back into civilian life. No parades, no speeches, just a simple return to Detroit. But his legacy lived on. The same principles he used to mass-produce tanks would later shape post-war automobile manufacturing. Assembly lines grew faster, smarter, more flexible. What began as a wartime necessity had evolved into a foundation of modern industry. Knudsen had changed not only how wars were fought, but how the world built everything. His ideas influenced future industries, from aircraft to electronics, defining the modern production era. What had once been labeled impossible became the standard for progress. Historians now look back and see Knudsen's blueprint as one of the most underrated engineering revolutions in history. It wasn't about weaponry, it was about process. His ability to merge human organization with mechanical precision changed warfare forever. Every nation since has tried to replicate his formula for mass production. Few succeeded. What Knudsen proved was simple. That efficiency, when guided by vision and courage, could be as decisive as any weapon on the battlefield. Today, his methods are studied in business schools and military academies alike. They remind the world that true power often lies not in invention, but in execution. Today, the story of William Knudsen is often overshadowed by generals and battles. But without him, the tanks that liberated Europe might never have existed in such numbers. His impossible blueprint taught the world that innovation isn't born in laboratories alone. It's forged on factory floors, by the hands of workers who dare to think differently. As the assembly lines fell silent after the war, Knudsen's machines rolled into history, carrying with them the proof that vision can turn even steel into strategy. In every Sherman that still rests in museums, his legacy endures, the perfect fusion of man, machine, and momentum. Knudsen turned Detroit's heartbeat into the sound of freedom itself.